All right, what we have here is a momentum and impulse problem. We've got a basketball being dropped from a height of 5 meters, hitting a force gauge, and bouncing back up 3 meters. We also know that the force gauge during this situation, when the ball hits, registers 218 newtons. We also know that the mass of the ball is 0.62 kilograms. Okay? So the question is, how long is the ball in contact with the force gauge? Okay? Now, in this kind of problem, it's a three-part problem. Okay? Any collision has 3 parts. There's the before, the during, and the after. Okay, so let's look at the before. Okay, before everything happens, we've got essentially a kinematics problem, a ball falling. We've got a change in y of -5 meters. We've got an acceleration of -9.8. We've got a v initial of 0. And finally, we can solve from that, we can find v final. Okay, v final is going to be solved for by saying that v final squared equals v initial squared plus 2a delta x. V initial is 0, so we get 2 times 9.8 times delta x. We get v final squared equals 2 times -9.8 times -5 equals 98, and v final equals 9.9. Okay? We also have an after. Okay, so let's take care of after here. Okay, after the ball bounces back up 3 meters, okay, we have a v final of 0, right, because it reaches its highest point. Okay, it's at 0. Again, we have acceleration is -9.8. Here we're going to take v initial, okay, and find it, and it's going to end up being that the same equation, v final squares equals v initial squared plus 2a delta x. Okay, we get 0, v initial squared plus, minus 19.6 times 3. And we get v initial comes out to be 7.7. Ooh, and I made a mistake a second ago. This v final should be negative. Okay? It's squared, so it wouldn't necessarily be obvious that that's true, but it's got to be negative because the ball is going down. Okay, we know physics-wise that it's going down, therefore we know that our answer should be negative, not positive. And again, since it's a square root, we can take the positive or negative. Okay? Alright, so we got our before and after. What about our during? Okay? Well, during the thing, we have this kind of connection going on here. Excuse me. We've got the before leads to the during. So our final in the before is actually going to be our initial for the during. So during v initial equals -9.9. And the final is going to be the initial part of the after. So we get 7.7. Okay, this is because these things are all connected in order. They're consequential. After the before happens, then the during happens, then the after. So at those endpoints, they have to match up. Okay? Now, if we want to know time, we have to figure out the impulse. Because impulse is equal to force times time. Impulse is also equal to the change in momentum. So we can find the change in momentum, we can find the time because we've got the force. Okay? So, momentum initial is going to be -9.9 times 0.62, and momentum final is going to be 7.7 times 0.62. Those things are going to come out to be 4.77 for the final, and -6.14. Now, for a change in momentum, we're going to have 4.77 minus -6.14. Okay? And that's going to give us 10.91. We then equate that to force times time, and we get a time of just over 0.05 seconds. And that tells us the amount of impact time when the ball is being deformed and kind of like in contact with the ground. Now this is only going to give us an approximation because the honest truth is that the ball is not going to have a constant force of 218. No collision is going to have a constant force throughout. Okay? But it's a pretty good approximation.